And unfortunately, what happens is a lot of people, they go straight to Power Query, they bring in a bunch of data, and then they go to the report section and they start building a bunch of visuals. And then things start to break down pretty early because they didn't do any modeling to begin with. So basically, you want to use the right tool for the job. So Power Query is your best tool for data modeling, and Power BI slash DAX, which is where you write your measures, that's your best tool for data analysis. So don't do modeling in DAX and don't do analysis in Power Query. They're very different tools and they have their purposes. We'll talk a little bit about calculated columns. Calculated columns are in the DAX side. That generally, I would consider that to fall under data modeling, not always, but generally. So if you can push that back into Power Query, that is a good idea. Or you can push it all the way back to the source data. So, maybe if you're pulling stuff out of SQL, you may create a SQL view or add different tables or columns in your source. Creating calculated tables in Power BI, that could be data modeling, it could be analysis. So that's a little more of a gray area, and you've got a little bit more flexibility there. So what is data modeling and why should you do it? So basically your Power BI model is a collection of tables, and those tables have columns, and each of those columns has values and information. You need to arrange that data in a way that makes it easy to write measures, which are the formulas that you use in Power BI. And you need to make it easy to use, so your end user can use it as well. So if they're looking through the tables and they do the hover overs, they can see the field names and the tables as they're looking at the report, and they can understand where that data is coming from, even to the point of the Q&A feature in the service, where they can type in a simple question like, what customer had the most sales last month? The Power BI service can intelligently go back and figure out what your customer field is, your sales field, and bubble that information up for them. And a good data model is the key to making things like that possible. So there are a number of models that are available in databases. There is a flat or denormalized model, a star schema, and a snowflake schema. So a star schema is what we want to focus on, but I'm going to touch on what the other two are briefly. If you've ever worked in Excel and done the classic pivot table, you had to use a flat model. And you've all done this before if you've worked in Excel. You have 4 or 5 tables across different sheets. You create a new sheet and you use a bunch of VLOOKUPs and you bring everything into one massive table. And that's the only way pivot tables used to work in Excel. A star schema is where you have multiple tables, and you would have like what I would call the fact table, or your data. It's your sales or your purchase information or your inventory information. And then it is surrounded by one or more what we call dimension tables. So it would be your item list or your customer list or your date table, things of that nature. And it has one connection to each. And then there's another schema called the Snowflake schema. And if you've ever done any work in databases, whether it's SQL Server or Microsoft Access or Oracle, you're very familiar with the Snowflake schema. And those are great for database operations where you're doing add, change, and deletes. You're reading and writing records and making changes, but they are horrible for a query model. There is a person called Ralph Kimball, who he really wrote the book on analysis models for queries. And if you want to Google his name and dimensional modeling, you'll find his books, and you can read up a lot more about him. But understand that the tools that you're using, it's SQL Server Analysis Services, Power BI, or Power Pivot, are optimized for star schemas. And just for the technically inclined, when you launch Power BI or Power Pivot in an Excel model, you're actually launching a miniature version of a SQL Server Analysis Services instance on your computer. It's part why it takes so long to launch when you start Power BI. It's actually firing up SQL Server Analysis Services in the background. So it's all the same technology. And it is all heavily optimized for a star schema, and we'll get into that as we go along. So again, this is a flat table. It's very inefficient to have everything in this one table. It makes writing reports and measures very difficult. This is a Snowflake schema, and again, great for database operations where you're doing add, change, delete, but it is horrible for query operations. And part of the reason is you have your table here, this table here that's called fact internet sales. If you need to get the customer, or I'm sorry, the employee information from this, you would have to jump from this table to your territory table, and then find the employee field and jump to the employee table to figure out what employees were responsible for certain sales. And I call this a table hop. And the model is designed for one table hop for maximum efficiency. And when you have 2 or 3 or 4 table hops, it really starts to slow down. You can see down here in the lower right, you've got the product category that's 3 hops away. And that really slows down the model. It also makes writing your measures much more difficult because you're having to think, okay, I've got to go from this table to this table to this table, instead of consolidating everything into one massive product table where you may have this data repeated. And we'll get more into that in just a few minutes. This is a star schema, and this is what your goal is. Right here in the middle, you've got your sales table, and then you have a couple of fields, your product ID, your date, your customer ID. And then it has these would be the points of the star, right? So your customer, product, campaign, and your date dimensions. Each one of these is all of your dimension tables have a 1 next to them. That means the campaign ID, everything is unique. The campaign ID is never repeated. But then as you go into the sales table, you can have multiple campaign IDs. So this is a one-to-many relationship. And the arrow that points from the one to many, this is your filter direction. And that's what Suresh was talking about earlier. This is not a join like you would think of in a database. This is strictly a filter. And what it means is if you're modeling based on this campaign ID and you create a visual, when you drop that campaign ID into a visual, whether it's a table or bar chart, when you then do a calculation based on units, the campaign ID is going to be filtering how those units are totaled up. So it knows which units belong to which campaign ID. It does not go the other direction. And the reason it's also important to understand that this is not a join, if for some reason you had a campaign ID in the sales table that did not exist in the dimension table, and you've probably seen this happen, you get this blank value in your campaign ID column in your report, and you have to figure out how to get rid of that. It's not being filtered out. This is not, again, if you're a database person, this is not a left join where only things in the campaign table cause the sales table to show up. It's simply the filter direction. If you have things in the sales table that don't exist in your campaign table, they will show up, but they'll give a blank value because there's nothing in the campaign table to represent that. So does anybody have any questions about that so far, or anything that I've said at this point? Okay. So that's the star schema. That's what we want to build as we go through this. This next one is just a different view of that, and it focuses on the fact that everything in the points of the star have 1 in them, and the star schema, the fact table in the middle has many. Okay, so let's get started with just some basic concepts, some settings, some preferences that you probably want to do when you're starting your work. First of all, in Power BI, you generally want to disable automatic date time intelligence. Okay, I'm going to go into my Power BI model. So can you see my Power BI screen here. Shref,
Yes.
is that showing up for you now?
Yes.
Perfect. Okay. So I'm going to go into File, Options. And there are two settings that you may want to look at. So under Data Load in the Global section, I have disabled Auto Date Time for new files. Okay. That means all new files that I create will not have automatic date time intelligence. And I'm going to explain what that means in just a minute. It does not affect any prior files you created. So if you have a bunch of files in the past that you've done, you would go down, you would open up options just like this, and then you'd go into the current file and you would disable this. Now I have this enabled right now for a specific reason, but I'm going to disable it in a few minutes and I'll show you why. So when you have automatic date time intelligence created, what Power BI does is it creates a date table for every single date field in your model. So if you look at my model over here, I only have about 6 or 7 tables. But let me show you what's really in this model right now with this automatic date time intelligence. And I'm going to be using a tool called DAX Studio. If you're a beginner, you do not want to be using this. If you're intermediate, you might want to think about it. But I just want to show you what's behind the scenes of this table. These are all the tables that are really in the model. And you see these local date tables? Those are the hidden date tables. So what Power BI has done is it has found about 9 date fields in my model and created 9 date tables. That can be a little confusing to work with. And let me show you why that can also be a problem from a performance standpoint. I'm going to count the number of rows in the first date table. Okay. What did I do? Oh. Okay. Come on. Count rows. Wow, if I could type tonight, that would be great. Here we go. Okay, 365. So whatever date field this found, it was 1 year's worth of data. And what it does is it finds a date field and it finds the earliest and latest date and then creates a list of dates consecutively. So it obviously found somewhere January 31 and December 31, created a full year. Watch what happens though when I look at the second one. $2.9 million records are in this date table. Why in the world would there be 2.9 million date records? What has happened is, I'm going to go into, this is the supplier table. This is really common with businesses. This is a some sort of table of all the suppliers and what their contract is good through. In an ERP system, there is almost never an option to say it's good until I say otherwise. You have to put in a final date. So what people do is they put in this ridiculously large date. And here, this model shows December 31st of 9999. So it's 8,000 years in the future. Power BI created a date table for that. That's crazy. So that's why I turn off automatic date time, because it creates these huge files that can have ridiculous ranges of dates. If you have a table that has birthdays in there, for example, it could go back to the early 1900s for some people, even though you're never going to do any date time intelligence based on their birthday just because they're an employee, if this is a sales model. So I always disable that. Now, the other thing that can be a little frustrating is if you look at these date fields, it's not just the date. You see how it has this little date next to it and then this arrow? What has happened is it has created a hierarchy for every single date. So it's got year, quarter, month, and day. Well, if you go over here and you just want to create a quick table and you drag the date field, you automatically get all those fields. And I have never talked to anybody that likes that. Now, maybe you do, but for the most part, people just don't want it. And then they go here and you turn it off. Valid from. So now that's gone. However, if you go over here to options, I'm going to turn off automatic time intelligence. It gets rid of those hierarchies. Now my date is a single date. If I go back here, you'll notice that DAX Studio refreshed the model. Now I only have my tables. Those fictitious date tables are no longer there. This file will shrink. Right now it's something like 80 meg. It will shrink to less than 2 or 3 meg when I resave it. So it can cause size bloat, performance issues, etc. Now, if you've gotten rid of your date table, I'm sorry, the automatic date time intelligence, you do have to make sure that you have your own date table. And this particular model has one that came from the data source. So I did not even have to create, actually this one I did create, but many data sources has its own date table that you can bring in, and that's just fine. There's a lot of them on SQL Server, SQL Server Analysis Services has them, etc. I tend to prefer to create my own date tables because I have a number of fields here that I like to add, and then it's also very easy for me to add other fields. Once you do that, though, you need to make sure that you right-click on the table. You want to mark it as a date table, and then select your date column. And it will validate and make sure that everything's okay. And for it, validation means two things. One, it's a date field. And two, there's no consecutive, everything is consecutive and there's no duplicates. So if it's 1 year, it's January 1st through December 31st, no skips, no duplicates, no anything. Then it becomes a date table, and then you can use all the date time intelligence functions like parallel period, the month to date, total year to date, etc. So I don't want to get into a lot of details on how to create date tables in detail, but I did want to show you the very basics and how simple it is. So I'm going to go to the home section here, and I'm going to hit transform data. This is going to launch Power Query for me. So I'm going to give you a couple of real quick tips to do a super fast date table in Power Query. We're going to create a new blank query. We're just going to start from scratch. We're not going to start from anything else. And Power Query has a feature called a list. So a list is simply, it's in these squiggly brackets, 1.12 as an example. So you can see what I've typed in there. What that's going to do is give me a simple list, 1 to 12. That's it. So now I just want to create another list, but I want it to be my date range. So I'm going to get rid of the 1 to 12, and I'm going to type, Power Query has slightly different syntax than Excel, but you're definitely going to recognize this. If I type date 2019, 1, date 2020, 12, 31. And then I hit enter, I'm going to get a nice error. Lists have to be numbers. They can't be dates. We're going to fix that in just a second. It's very simple. But what I wanted you to notice is I automatically created it for the full fiscal year. That is not a requirement, but it is a recommendation because as you start developing models, it is easier to work in general if every calendar year that's in your date table has the full range of dates. So let's say your business started in, July 1st, but it has a calendar year. That first year, you still want to have the date table start at January 1. If you have a fiscal year, your date table should be in the range of your fiscal year. So if your year starts August 1st, you want that to be August 1st through July 31st of the next year. Okay. To fix this, all we need to do is change these dates into numbers. So I'm going to wrap them in a formula called number from. Now I have a list of numbers from 43,466 on to whatever, and you probably recognize this. This is the exact same date methodology that Excel uses. These are dates, they're just not formatted properly. I'm going to convert this to a table real quick. There's a button up here in the upper left that I pressed. You can see here that I'm in a feature called List Tools. I press that to convert this to a table. I hit OK. I change this to a date. Now everything is a normal date, and I'm going to call this date. And then at this point, you start building the fields that you want. And I'm going to do 2 or 3 fields, very simple. You go to the Add Columns, Date. I'm going to add a year. I'm going to go back to the Date field, Date, Month, add the month. I'm going to add one more field just to show you what else it does. You can add the day of the week. I want the name of the day. So this is why in my table here, this is my date table that I normally build. I've got the month name, the short month name, the month year name, the ability to sort the month year name, quarter. I have all these fields. And then at the end, I have a bunch of true false values where I can do very fast filtering in the model and say, is it in the future? Is it in the current week? Is it in the current month? And it makes working in more complex DAX models and DAX measures, because I just say, only show me everything in the current month. And the current month is defined as what's today. Okay, it's May 28th or whatever today is. May 28th. It would pull everything that's in the month of May. So it makes it very easy to move through. So let me delete this because I don't want that. I was just messing around with that. But let me pause for just a second. Does anybody have any questions about date tables or anything that I've talked about so far?
You can also type in the question in the chat window if you prefer that way.
Yes, let me go back to the chat window, although I'm not sure what I'm going to see. Okay. Okay, so I don't see any questions. So I'm going to go back. Okay, so let's see, let me make sure I've covered everything. It is, okay, perfect. All right, so let's go back to the presentation. So that's why I always recommend to disable date time intelligence. You control the date table, you put in the columns you want, you get rid of those, to me, they're annoying little hierarchies in every single date field, and you certainly get rid of date tables that have anywhere from a few 100,000 to possibly a couple of million rows, depending on other dates in your model. One other thing I like to disable is something called automatic relationships. So if I go back into options and settings, unfortunately, there is no global way to do this. You have to do it on a per file basis. It's auto detect new relationships. The reason I do this is there has been more than once where Power BI has found a relationship between two fields that it wasn't correct. And when I started writing my measures, things weren't working properly. and I kept thinking I was doing something wrong in the measure. I had the coding wrong. I wasn't pulling the field right. And it turns out Power BI had linked to the wrong field. And so I had spent like, half an hour to an hour troubleshooting something that of a problem that I really didn't have. It was a problem in the model. So I always disable this. And then when I'm ready to go and create my relationships, which is done here, which we'll get into in a minute, I do it on my own. And I know what you're thinking, that doesn't look like a star schema, but actually it's a beautiful star schema, but I'm going to show you why in just a minute. Okay, so those are the two things that I generally do before I get to work on a file. Blank file, disable dates, disable automatic relationships. Okay, now you need to get your data. So 99% of the time, you're going to go into get data. It might be one of these services. You can click more, and you can get data from probably well over 100 sources. From SAP HANA, SharePoint folders, I do that a lot. I use Azure Data Lake, get all your data. What you do not want to do, though, is once you get your data, you do not want to press the load button on that first screen, okay? And I'm going to show you what that looks like in just a second. But the reason is you're going to go out to SQL Server and you're going to get 15, 20 tables because you need the customer table and you need these category tables and subcategory tables and employee tables and all that stuff. You don't want to bring that in because that is not a star schema by default. You've got to make it a star schema in Power Query. It will have unintelligible table names and field names. These are table names and field names created by computer developers, not to be used by humans. So things like Q&A in Power Query or in Power BI don't work because it doesn't say things like sales. It has all this camel case and weird field names. You're going to want to rename your field names and make the table names a little bit more user-friendly. It's going to have way more data than you likely need. You start pulling in tables from, I don't care if it's Excel files, SQL Server, CSV files, you could have hundreds of columns. You're probably not doing analysis on hundreds of columns. You want to get rid of as many columns as possible and only bring into your model what you need. It makes your model easier to understand. It makes it easier to write your measures. And it also speeds up your refresh and calculation times by not having all of that extra data. What you want to do once you brought that in is select transform. So this is the screen that, this is browsing through a SQL server. I've selected some fields, and unfortunately, Power BI has the load button in yellow. This is what you want to hit. Well, it's not what you want to hit because then what's going to happen is you're going to bring it into your model, and that's what your tables are going to look like. They're going to have all these names that, again, don't make a lot of sense, and you don't need all those tables in there. You might need data from all of those tables, but you're going to bring those in and you're going to consolidate your customer information into into one customer table, your item information into one item table, etc. You do all of that modeling in Power Query. So when I develop in Power Query, this is something called, let me zoom back out, Power Query Dependency View, and it's on the View tab of Power Query. And it just lets you have an overview of what work you've done. And you can see here that this all came in here. I've blotted out the SQL server that this came from, the name of it. But I just brought in 4, 5 tables from the server. But then I've done some work on each of these to do some transformations. And I've pulled some fields from here. I've copied them over to this table. I've done some mergers, some joins, etc. What's important to note is all of this work goes to this next slide. I'm only loading 3 tables. All of these other tables are just work to get to these final tables. I needed a date table, I needed a trial balance, and this table up here that's on the side of my screen is a chart of accounts. That's all I needed for this model. but I needed about 5 tables to get started, and I had a bunch of queries where I had to do a bunch of intermediate work. But I'm only loading 3 queries in this model. And that's the difference between just hitting load and getting this mess, or getting 3 very concise, deliberate tables that makes it much easier to do your work. So as an example, in Power Query, you may have this customer table and a buying group table, and they're linked this way. When you bring this into Power BI, you want it to look like this. One table, I've brought my purchasing power over here. It has duplicated the data. That's fine. Massive replication in repetition in dimension tables is just fine. That's how it was designed to work. And the DAX model in Power BI is designed for this, and it works extremely fast. It doesn't actually store, I don't know what that is, maybe 20 fields. It doesn't actually store that in 20 different records. It would actually only store 2, and then it has some metadata that it uses to compress that, and it knows where it was related in these side tables. So it will actually reduce the size by having this repetition here. Again, this is what this product was designed to do, and it was optimized for this. So it works very well with this repetition in these dimension tables. So just a few do's and don'ts on data modeling. Try to stick with a one-to-many relationship where possible. There are other types of relationships. There's a one-to-one relationship. There's many-to-many. I would suggest if you have a one-to-one relationship, you should probably consider merging those into a single table. I don't really know why there would be a good reason to have a one-to-one relationship intentionally. I'm not saying there's no reason, but it would just be a pretty rare occurrence. Relatively new to Power BI, I think this was maybe about 1.5 years ago, they came up with the ability to have many-to-many relationships. Avoid this until you know exactly what you're doing. I have seen a lot of models fail because people put many-to-many relationships in there, and it was affecting tables that might have been 1 or 2 tables away because of how that filtering works. You really have to understand what you're doing. If you have the need for many-to-many relationship, you should opt for a bridge table. I'll cover that in just a few minutes. Once you brought your fields in, you want to hide the fields on the many side from the report view. What do I mean by that? Let's go back to this model. And if I just look at the sales, here I've got the date, okay? And I can see that the date is linked primarily to the invoice date key. I should not be using the invoice date key in my model. I should always be using the date. I should be using what's on the one side, not the many side. So after I create my relationships, I hide it. And you'll see that's going to be grayed out. It's got a little eyeball that shows it's being hidden. And when I go to write my reports, that field will not be there. I can still use it if I need to in my measures, but I won't be able to accidentally use it in the model. Why is that important? Well, let's stick with this sales side here for just a minute. Let me explain a little bit about my model first. This is the model view, and you can see I have all these tables. Ignore this little measure table up here. These are all my tables, and you may think that does not look like a star schema. There's stuff going all over the place. This is actually 2 star schemas. I have a purchase table here and a sales table. These 2 tables are not related to each other, but they have a lot of common dimension tables. The sales table, they both link to the item table, for example, because you buy the items in the purchase table, you sell it in the sales table. They both link to the date table. They do not both link to the customer table. They don't both link to the supplier table. So they have some commonality. Power BI makes this a little easier to deal with. You can't do anything about this all tables view other than move things around maybe to make things easier and create relationships. But you can add new model views. So this is my sales model, okay? And I've only pulled in those tables from the sales model. This helps me keep stuff straight in my head. Now, you'll notice that I put all my dimension tables at the top and the sales here at the bottom. This is just a mental thing with me. The filter direction runs downhill. I know that my date table, customer table, item table filters the sales table. The filter does not run uphill. It has nothing to do with performance. It has to do with me, just understanding how the model flows, and I visualize how that works. If I go over here to my purchases tab, same thing. I only have 4 tables here. These tables filter the purchasing amount. So what was the example? Okay, so what I want to do is, because my items are in both my sales table and my purchase table, I want to create a visual that shows what are my sales and what are my purchases by item. So how would I do that? Well, if I go back here to the visual layer, I've already created a basic table. Okay, I have the stock item number, the description, and total sales. Okay, so let me close my date table here. So you can see that I'm pulling stuff from the item table, the sales table, and then I have a measure table. And I'll explain how the measure table works in just a minute. But what I did is I pulled the stock item key from the sales table. I knew that was linking to my item table, so that gives me the stock item description. And then I wrote a measure, and that measure is simply doing a sum of what my sales are, excluding tax. Very simple calculation. I have also done another measure for total purchases here that simply takes my purchase price, I'm sorry, the ordered quantity, and multiplies it by the unit price in the item table using the SumX formula. If I bring that over to this table, I'm just going to tell you, it's not going to work. You can see now my stock item key, massive duplication. This item has different descriptions, and my sales is blank. Now, you'll notice, if you remember what it was before I drug this in, it was $174 million. That hasn't changed, but I have a lot of blanks. But what's happened is I have billions in purchases, and things are massively duplicated. Well, so here's the problem. I brought in the stock item key from the sales table. It's connected to the item table, but it is not filtering the item table. So it essentially is it's allowing everything from the item table to be brought in. It's not filtering by individual stock item number. And then when the item table carries it through to the purchase table, it's just it's just a mess. So it's not what I need. Now, there are 2 ways to fix this. There's 3 ways. I'm going to show you 2 ways you shouldn't use and 1 way that we're going to use. I could double click this and change this to bidirectional. That's a bad idea. It's going to fix this problem. It's probably going to cause other problems in the model. And the larger your model is, the more likely you're going to get an error that's saying this is not even allowed. So you should avoid, it's called bidirectional cross filtering. Avoid that at all, if at all possible. There are times to use it. This is not one of those times. This is not working because of poor modeling, not because I have special circumstances. Another way to fix it, so I'm going to go, I've created another one. I created another measure called total purchases bidirectional, okay? So, let's see this thing. Okay, see the whole measure now. So there is a feature called, or it's a function called cross filter. I can turn on bidirectional cross filtering in a measure for one calculation. And what it's doing is it's taking my original total purchases, which remember was simply the total of my units times the unit cost, but it is saying between the item table and the sales table, it is saying turn on, my awesome drawing skills here, turn on cross filtering for this measure only. That's perfectly acceptable. I will do that quite often in a model. It's still not the fix for this particular issue. This is just a poor use of how I'm doing the data, but this is a way to do it. The cross filter function is not really a function you can use on its own. It's called a calculate modifier. So you would use calculate, and what this does is calculate says, okay, I need to go back and redo the purchases measure by turning on the cross filtering both ways between this item stock key and the item in the sales table. And then if you'll notice, these are correct results. So I have the right information now. The true way to fix this, though, is the problem is this item stock key that I used is from the sales table. That's the wrong place. I should have pulled the item stock key from the item table. I'm going to get rid of that. And then because the item is a number, Power BI wants to add it. I'm going to say don't summarize. Now I have my item stock key and everything is right. And I did not use my more complex bidirectional measure. I'm simply using the normal sales, total purchases, and what's happening is everything is being driven off of this table, and it's controlling both of these and all measures that relate to those. So to prevent yourself from having those kind of issues, once you've created that relationship, I'm circling back to where I was 5 minutes ago. If I'm using the item stock key here and it's linked over here, I don't ever want to use that in my report view. I'm going to hide it. Now it's going to disappear and I cannot accidentally use that. That's especially important for date fields. Once you've got your date field, you want to pretty much hide all the other dates in your model and only use the date field. Because if you use the date from your fact tables in a time intelligence function, you won't not only get the wrong answer, you will get nothing. It will return blanks. So you need to always use your dates. So I would go back and look at, if I go to the date table here, so I've already hidden the invoice date key. I've got the delivery date key. I could hide that, etc. So that's why you want to make sure when you're here. This is the other reason I like to do my own relationship creation. Once I create the relationship between employee key here and here, I know to go turn it off. If I just let Power BI do all the relationships, well, then I just go get to work on the model or on the visuals, and then I start running into problems. I've dragged the wrong field in. You can spend an hour trying to figure out why your things aren't working, and it's because you simply brought in the wrong item number. You brought the item number in from a fact table instead of bringing it in from the correct table. So let me pause right there and see if anybody has any questions before I go on. Go back to the Q&A here. So yeah, so someone said, Bill said that automatic relationships are annoying when you're reviewing someone else's model and troubleshooting because you're trying to figure out which ones are intended. And that's exactly right. Power BI will create relationships that were not that are not needed. And if you're trying to troubleshoot measures, it's going to take it's going to take a while to untangle that mess. So create your own relationships and make sure they're going the right direction. Okay. Okay, so that all of that was this, hiding fields on the mini side from the report view. Once you get those done, I have a number of models where my fact table is entirely hidden. Everything is hidden. The values and the keys, the date key, the stock invoice key. Well, how do I do that? So if I go back to my model here, as I told you earlier, I have this measure table, okay? And if I look in my overall model view, it shows up here. It's a disconnected table, but if you look at it here, let me zoom out a little bit. It only has measures in there. So how did I create that? To create a measure table, measures, they have to reside in a table because Power BI doesn't know where else to store them. Unfortunately, it doesn't have a drawer or a folder that you can just put them in. So I'm going to call this measures test. You cannot call it measures. That's a reserved word, but you can call it measure. Actually, you can't call it measure, but you can call it measures. But I'm going to create 2 or 3 measure tables in a model, depending on how complex the model is. So if you hit load, Power BI will create this table, and it will put it's thinking. Okay. Okay, here we go. So when it creates it, it sorts it alphabetically. So it's right here. To make this a valid measure table, I'm going to take this measure and I'm going to move it to that table. Again, measures don't care where they reside. It's not, measures aren't part of the model. Measures use the model. They don't impact the model. Even when you do something like the cross filter function inside of a calculate, you're modifying the model for that measure, but you are not impacting the model for everything else. So it's a one-way relationship. Measures just analyze the data. They don't impact your table or your model. So now if I go into this measures test, let me zoom in here so you can see what I'm doing. This is the final trick. You right-click on that. You do not hide in report view. You actually delete that column from the model. Now my measure table only has a measure in it. Now, I don't know when it will happen. If I were to close this and reopen it, it would change that table model to a calculator. But if I work in this model for a couple of hours, it will do it on its own at some point. At some point, Power BI goes through and cleans up the tables. So if you really want that to be a measure and it will put it at the top with a little calculator icon, save, close, reopen, and it'll do that. I'm not going to do that now for time's sake. Then, because I've done that, if I look at my sales table, I would hide the city key. I would create measures for profits, quantities. I would put all those in my measures table. I could completely hide my sales table. I could completely hide my purchase table. That makes the model cleaner. Then I'm doing everything based on dimensions and measures. And I don't have to worry about dragging the wrong field in or doing the wrong type of analysis. Okay. So again, do's and don'ts in modeling. We've gone through the do's, I believe. Don't enable bidirectional filtering. You can, again, there are certain circumstances where that's possible, but I would say you need to be intermediate to advanced to use it. Same thing with many-to-many relationships. I would say with many-to-many, you need to be advanced, not even intermediate. You need to be an advanced user before you turn that on. Don't use one-to-one relationships as a rule. Go back into Power Query, put that into a separate or into a single table. Don't relate fact tables to each other. So what I would not want to do is, in this model, when I was trying to get my measures working for the sales and the purchases based on the stock item key, you don't want to do something like this where you merge, I think I just put that to the wrong thing. Stock item key here, stock item key here. It has many-to-many. Okay, if I turn that on, it's gonna really cause problems with the measures, and it might even. I'm just gonna try this and see what happens because I'm kind of done measures, so it doesn't really matter. Yeah. So, but whether or not these work reliably anymore is anyone's guess because I would not consider myself an expert in this. So you want to be very careful about doing that. It can also create what's called ambiguity in the model. And what that means is between tables, you've got filter directions. It can become very difficult for Power BI to determine what that is. Oh, look at this. It wouldn't let me turn the thing on. That's why things still look like they're working. Yeah, I could not create this. It's not even going to let me make that an active relationship because that would introduce ambiguity between the date and sales, because both of those are connected to both purchases and sales are connected to the date table, which is somewhere right here. It creates a path where Power BI doesn't know how to get to the date table. Does it go through the sales table or does it go through the purchase table? So it won't even let you turn that on. So again, many-to-many, don't do that. And I want to delete what I want to do. So right click, delete, that's gone. Okay. So don't relate fact tables to each other was what that whole exercise was for. Try not to relate dimension tables to each other. If you're doing that, you're starting a Snowflake schema. It doesn't mean there's never a time to do it. It should be a last resort. And then, as I said, don't use many or most of the fields from your fact tables and visuals. Try to use measures and use fields from your dimension tables. It doesn't mean you never use them from your fact tables. There might be some information from a sales table. For example, maybe the shipping company is in there. There's not necessarily a reason to create a shipping company dimension table. You could use that from your sales table, but almost all your values, you want to create measures and hide those fields in your fact tables. So let's see, just want to make sure, see if there's any questions. So let's see. So let me see if I can answer this question that Amit has asked. If I have two tables, table 1 equals date 1 and incident number, table 2 has date 2 and lot ID, I want to create a measure for the incident ratio, which is a count of incident by date 1 divided by a count by lot 2 of date 2. How would this be possible using the date table? So without seeing your whole model and understanding, you would do all of this based on the date in the date table, and you would relate the date field in your date table to table 1, date 1, and to table 2, date 2. And then you would create your measures based on that relationship where your date table is filtering. It would be similar to my model that I have here. In fact, I could create a model if I wanted to. I'm sorry, I'm not creating a model in these subtabs. I'm simply showing a different view of the same model. So here's my date table, and I'm going to bring my purchases table and my sales table over here. Now, I didn't create those relationships here. It already existed here. This is the whole model. This is simply a way for you to have a simple view of a more a smaller piece of your model without having to look at all 20 tables at once. So I would create any visuals and any measures based on this date table, which is filtering both my sales table and my purchase table. If I wanted any measures, I could actually do this, I think, fairly quickly here. Let's create a new tab. Go, what you doing? I think this thing is in my way. Let me see if I can hide this. There we go. Okay. So if I did sales, create a table, I'm going to drag my date in here. Okay. And then I'm going to go up to my measure table, total purchases, which I put in the wrong place. Then this is my test table. And then my real measure table, total sales. There are my total sales. That's the wrong one. I want my plain total purchases. I don't want the bidirectional because I don't need that one. Now by date, so my date comes from my date table. It's filtering both the sales table and the purchases table. So these measures work perfectly. So I know every day what my sales and purchases are. So I hope, Amit, that answers your question. And if not, we can follow up later. But that just shows ad hoc. I was able to very quickly do that because my date table was controlling the filtering of the other two tables, and it just worked. You could, you've got a division here of date table divided by the lot. That starts to get a little bit more complex, but I think you would use the calculate with the filtering, the cross filter. So we can kind of take that offline. I don't want to dig too deep into that. But the point is, in a star schema, what I've done, even though I have 2 star schemas in my model, it's very simple to move between them because they all share common dimension tables, dates, customers, items, etc. Okay. Any other questions or clarifications before I move on? Okay. All right, good. So let's go back to the presentation. Okay. So now that we've kind of understood, and again, you're going to be bringing all these tables in. You're going to be spending, it is not uncommon for me to spend a couple of hours in Power Query doing all of this work. I have a whiteboard. I'm writing down how does this stuff come together because I'm thinking in the future, what does my star schema need to look like? What does that final thing need to look like? So I don't just grab a bunch of tables and start creating visuals. That's where you run into problems. I spend a lot of time in Power Query, and I'm not going to go into the technical of that. It goes way beyond the scope of this seminar or this discussion. But I'll spend a tremendous amount of time in there. Once I've brought all that in, that's when you start your detailed analysis. You create your relationships, then you start creating your measures, then you start building your formulas for your visuals. So we've created a measure table. Something you want to be careful of in measures is using measures inside of other measures, okay? You've probably read about the calculate function. It has some very special characteristics. I'm not going to get into the details, but it does something called context transition. What that does is it makes a copy of all the filters for your model for that measure. Then it deletes all the filters. Then it creates a row context, okay, which is going to go through every single row in your table, in your model. Then it reapplies those filters to the row context. That is a very expensive transition. The reason I say you need to be careful with that is if you use a measure inside of another measure, it automatically, Power BI automatically wraps a calculator around that. Just be careful when you're doing that. I will frequently copy the code from a measure and put it inside another measure to prevent that from happening. Now, it depends on how complex your measures are. If they're 5 or 10 or 15 rows, that's not a big deal. If you're copying 70 or 80 rows from an especially complex measure, probably not a good idea. So it's not a don't do this, it's a be careful when you do it. It's not like Excel where you just reference other formulas and other cells and everything's all great. That has a cost in Power BI because of the way the model is built. As a rule, don't use calculated columns. Again, use the right tool for the job. Calculated columns are typically modeling, not analysis. There are better ways to do it. Use a measure or go back into Power Query and create that same data in Power Query and then bring it into Power BI as it's considered a native column. Power BI doesn't know if Power Query created it or if it was just imported directly. So try to create it there, or again, go back to your source. Go back to SQL Server, add it in a view, or go back into your Excel file if that's a source, create another column, add it there, then bring it in. And I've got this link here to an article that Matt Allington wrote called Calculated Columns Are Evil. I don't think the column's actually called that, but he actually says that in the article. And their calculated columns are they're like flies to honey. To an Excel user, because you think, oh, this looks like an Excel. If I go here and I'm in this table view and I want to go into the sales table and I want to add a discount, well, this is great. This is just like Excel, and I'll do this. That has a cost. Calculated columns, they don't compress as well. I think I've got, yeah, they consume more memory and processing power than measures do. They take up space. You can run into circular dependency issues very quickly if you don't know exactly what you're doing. So again, for most scenarios, stay away from them. Use Power Query, change your source table. So once again, the answer is not never, but it is rarely ever. You want to avoid those if at all possible. And then you also want to use implicit measures. I'm sorry, you don't want to use implicit measures. You want to use explicit measures. Why is that? Okay, so if I go back into this model here, and let's just say that I wanted to have a very simple bar chart. So I'm going to move this over here. I'm going to create a bar chart here, and I want I need the item description here. Stock item, is that it? Yeah, so I want this. And then I want sales. You can, I think I have total excluding sales. You can drag this in here. Oops, I did this in the value section. And get your sales, okay? Now, the problem is you didn't control what that did. By default, it did a sum. You can change this. But what happens if you go in here and you start doing a bunch of conditional formatting or other special mechanisms, and then you find out you need to tweak this measure and you need to make it show something else. Maybe you need to multiply it by 0.9 to show some sort of discount. It's impossible to do because you've pulled the field in. If I pulled total sales in, and I have found out, oh, this calculation is not exactly correct, I need to multiply it by 0.9, I simply click on the measure. And everything's done. I don't have to drag a new field in, redo any conditional formatting or any numeric formatting or anything like that. So you always want to drag in an actual measure. And again, this is why if you have gone through, created the measures, then you hide these all these numeric fields, the profit, the quantities. If you hide those in your model, you won't be tempted to do that. So it's just good practice to always use what's called an explicit measure, which is what you're deliberately creating, not an implicit measure that you're just dragging fields in. Okay. So we've already talked about calculated columns. So, you know, we're kind of wrapping it up here. I hope I've shown how, if you spend a little bit of time in forethought, planning the data you're going to bring it in, how you're going to create those tables into one dimension table per, call it a group. You know, you got your customers. Maybe you have 4 or 5 tables in your source data that have your customer information, from territory to salespeople that are representing them to all that. Bring that into one customer table with a lot of columns instead of 5 tables with a few columns. Same thing with your items, anything else. You bring in your fact table or multiple fact tables. Make the model as small as possible by not having all these tables. I showed you that where you've got 40 tables and between them about 800 columns. Bring in only what you need. You can see how it makes the schema will make the analysis much easier because things just start to work, and your relationships, you build them purposely and thoughtfully. You decide what needs to be created, and you know exactly what's going on as you're using it. So let's see if we have any questions. Oh, so here's a good one. Sana Ho. So is asking, in the case where the date ranges keep changing quarters, does that mean you have to recreate the date table? No, you do not. So I'm glad you asked. I have written an article. All of my date tables are actually dynamic. So I will put this here. I'm not going to go through this article, but I am going to paste the link here. This will show you basically how in Power Query, using the exact same method I showed you earlier, how to create your date table. So you can see here that I've got, this number from, and right now I've hard coded some dates in. I'm going to get further down into this. And what I've done is I have created some variables. And those variables are coming from your source data. So as a new year happens, this latest date increases. If you decide to purge data from your system and you no longer have data from 2010 and now it goes to 2015, this earliest date will self-correct and will move from 2010 to 2015, keeping your date table in that narrow range. And you can get much more complex with it. I have a number of date tables that look at 3 or 4 different tables, maybe purchases, purchase orders, invoices, and it finds the minimum date from all those tables. That's the first date in my date table. And then it will do the same thing with the latest date. It will look at the latest date in all those and determine what the latest date is. I have models that I created 3 years ago I haven't touched, but those date tables just keep generating new years every time, new data is added. So you can be completely dynamic with that. And I think what people don't understand that Power Query has that power. And so when they create a date table, they think, oh, great way to create a new table is new table, and they create a DAX. And I think I'm going to regret doing this. Calendar auto. Actually, and my fiscal year end is 12. They do this. Well, Calendar Auto has the exact same problem that Automatic Date Time Intelligence has. If I go to that table It has 2.9 million rows in it. That's ridiculous because it went through all the date ranges in the table, in all my tables, the whole model, and created one from there until December 31st of 99.99. And what's worse is now all these great columns that you need, like your month, year, quarter, all that, now you have to create those using columns in DAX. None of that's going to compress. Every time your model loads, those have to be recalculated on the fly by the service. It's going to slow the model down and make it larger. So again, use Power Query. It's a little more work because you don't just get to type calendar auto, but trust me, it's going to make your model much faster in the long run and much smaller. So I hope I have answered that question. Go back to this. So thank you. I'm not sure if there's a solution for the increasing ID numbers. I would have to talk to you a little bit offline about that. I'm happy to do that later to understand exactly what you mean by that. But you can have in Power Query, you can auto increment things using an index field or using there's other functions that you can use to increase those. You can create lists out of just about any number. So depending on how that works, I'm confident that what you want to do is possible. It's just a matter of figuring out how that would work. So any other questions about date tables, Power Query, or anything I've covered so far? Okay, so let me go back to, sorry, that's my Twitter feed, which is all, by the way, if you follow me on Twitter, you're not going to get anything except Excel, Power BI, and the occasional dad joke. That's all I do. So my Twitter feed is a fairly safe feed to follow. I wanted to go back to the PowerPoint here. Okay. Okay. So special considerations, things that go beyond the scope of this course, but things you're going to have to understand and at least allow for. Not all model lends themselves to this ideal star schema, or they require more detailed thought. Header tables and detail tables. So you may not have a nice, clean sales table. You might have a order header field that has things like the invoice number, the total sales amount, other things that are at the top level, like maybe the shipping costs or an order discount. And then you have an order detail table. And the order detail table has things like the item numbers, the prices, the actual line item sales, but it doesn't have things like shipping costs and discounts because maybe those are not done at the item level, they're done at the header level. So you have to understand how to take those things into account. Bridge tables. Bridge tables are tables that you would use to join two other tables through a many-to-many relationship. And you could do that either in Power Query or in DAX. Actually, that's a little bit easier to use in DAX, and doing a calculated table in DAX is perfectly acceptable for this purpose. You can have composite models, which gets a little more advanced, especially as you get into premium capacity, where you have some tables are incremental, some tables are not, some tables are direct, some tables are import. That makes the model more complex. You can have disconnected tables, tables that are not actually related to anything, but that you might need to use special measures such as treat as to get that information. You can also have tables with different granularities. So budgets can be at the monthly level, whereas your sales are at the daily level. How do you integrate those? So these, I would say these are all advanced. These are beyond the scope of this. I just want to bring them up that if you're thinking through your model and you have these and you're thinking, how do I do that and what Ed's talked about today? Well, the reality is it's not going to work perfectly. You start with the fundamentals, then you have to learn a little bit more of this advanced stuff. I suspect Paul Turley in our next session will talk about these in a little bit of detail, but I want to recommend a couple of resources that will address these directly. These, if you're a beginner and you're just getting started, or maybe you're even early intermediate, I think these are the best 3 books you can buy on learning how to work with this. This one by Alberto Ferraro and Marco Russo is analyzing data with Power BI and Microsoft Power Pivot. They do not go into any DAX or Power Query of any substance. Everything they do is the theory of modeling. And they do talk about in detail these bridge tables, these disconnected tables, composite models, etc. That is a perfect book on theory, and it's a couple hundred pages, but it's a great resource. To get into the beginning of Power BI, this is a book by Matt Allington. His is, it goes from the very, very basics through what I would consider intermediate steps. You get beyond this book, and then you start getting into the, what I would call the magnum opus of DAX, the definitive guide to DAX, which is also by Ferrari and Russo. But do not start with that book. If you're not familiar with DAX, don't get that other book. Start with this one or a similar beginner book that starts in this basic level, takes you up through it. To really enhance your Power Query skills in creating these models, this book by Joe Revive this one is the whole gamut. It starts at a very basic level, and it goes all the way through level 10 of Power Query, through custom functions, through the list aggregate, and list generate functions. So this is a great resource to have. So if you have nothing and want to get, a couple of resources, I would start with this one, the orange one. And then as you start really getting into building the model, get these other two, and they'll help you bring everything together. So that is everything that I had. So I want to know if there's any other questions. So let's see. So Dwayne has a question. I'm curious, since token dates can use so many dates with date time functionality. So I'm not clear when you say, has anyone suggested to MS to add a configuration object, configuration option to ignore certain dates? I'm not sure what you're referring to by saying ignore certain dates. So if you can clarify that, and please turn on your microphone and just ask the question to the group. You don't have to do everything with typing. Oh, okay, right. So no. So in Power Query, you can do that. For example, in Power Query, you might just say, I just want to get rid of that date. Or you could convert all those future dates to null so they don't show up. But as far as in the auto date time intelligence to say ignore those, no, it finds the smallest date and the largest date and does everything in between. And I don't know if anybody suggested anything to Microsoft, but that would be kind of a fundamental change to the SQL Server Analysis Services, which is again the engine